which is in the measurement. So so the thing is that by using this, we are doing the FFT based OMP orthogonal matching pursuit and the dynamic group sparsity. We are doing the measurement, the acquisition peak, what I said earlier. But the thing is that this line actually represents that the CFR. CFR means that the constant fall alarm ratio. Based on the constant fall alarm ratio, we can see that the dynamic goods sparsity maximum peak it has been done, and it has the how many buffer we can take 124, 512. Based on that, we can actually doing on this compressive sensing based receiver. So these are the comparison, and we can see that the red one actually had the highest value, and it is based on the dynamic group sparsity. So So this dynamic sparsity actually has been done by the optimization technology. So we can say that if we do that, the compressive sensing based, it's called all information converter. The all information converter actually works based in that GPS's GLONASS Galileo receiver, which is actually done by the European Union. So that actually has the best result. And we also doing that the binary offset carrier signal for our GOGON and IRNSS sites, but we can also shift to the MBSS signal. But if we think of computation complexity, then we can work on the dynamic sparsity. And it has the time bandwidth product of the and we also do the basis vector. The basis vector name is polar spiral wave function, and or the DPSS discrete polar spiral sequence, which is and all the work on the MATLAB has been done, Simulink based MATLAB. The Simulink work I will show later on my next work. And here actually the all this work, the computational complexity, if we think of the dynamic group sparsity measurement is based, and the K is the time bandwidth product is the 366. So yes, so these are the few selected few references, and I am open for the uh, questionnaire. Thank you.
Any queries or questions from the audience regarding the presentation? Okay. Thank you, Tamesh, sir. Now let's continue with the next paper title. I would like to call Mr. Ramesh Chandra Nayak and his team for his paper title Smokeless Stove to Reduce Air Pollution, an Experimental Method.
This is the fifth one, this is the fifth paper.
Hello, madam, am I audible?
Yes, sir, you are audible.
Can you please confirm me my screen is visible or not?
Yes, sir, your screen is.
Okay, madam. Thank you. Respected organizing committee members, I'm Dr. Ramesh Chandra Nayak, Professor and Head, Mechanical Engineering Department, Synergy Institute of Technology, Bhubaneswar. And my co-authors are Praveen Pratish Sandha, Divya Prakash Barik, Ravi Narayan Bhui, Gaurav Kumar, Abhishek Kupasin Maji, and Snigdha Satkari. So The title of my work is Smokeless Stove to Reduce Air Pollution, an Experimental Method. So actually, this is a very new work, and this is a technology-based innovative work. We know generally from a calculation, from an observation, it has been found that more than 10% death of actually occurring due to air pollution reasons. And traditional cooking by using traditional chula is the smoke from the traditional chula is one of the major source for air pollution. Generally, in rural women are using this traditional chula for their cooking purpose, 3 times cooking purpose. So the smoke from the chula is producing producing a rich environment by which all the family members actually they are suffering due to that effect. So generally, traditional chulas are used by the rural women. Generally, the primary fuel is used such as wood and straw, but our work is separate. So in our work, that 2 types of fuel has been used. That primary and secondary fuel. The primary fuel is wood or straw, and secondary fuel is superheated steam. So generation of steam from water, the water initially converted to saturated water, then wet steam, saturated steam, and then the superheated steam. So by taking the concept, whatever the energy given to water for conversion of water to superheated steam, that all the energy and the superheated steam condition, that energy can be utilized for burning purpose. So that is the technology behind our work. So this is my preliminary discussion about my work. So now I want to explain the details experimental setup of our work. Generally, traditional chula, its working principle is very simple, but whatever the concept behind it, that a draft is there, primary fuel is there, and only due to burning that smoke generation is occurring, because of at that time complete burning is not possible. So that is the main reason for the traditional chula smoke, because we know the calorific value of the fuel generally depends. Due to calorific value, the complete burning of the fuel takes place. So that concept is also taken in our work. So this is my experimental setup. It consists of 3 cylinders. One is outer cylinder, middle cylinder, and the inner cylinder. The middle cylinder and the outer cylinder, there is an insulated layer is provided. Generally, in our work, we have used glass wool as superheated, as insulating material, and inside the inner cylinder, a superheater is provided. The function of the superheater is to convert water to steam. So that is the uniqueness of our work. So the detailed dimensions I will describe here, and this is my 2-dimensional diagram of my arrangement. So inside the combustion chamber or inside the inner cylinder, so this is the superheater, and this is the water tank. The water tank is connected with the superheater, and another side of the superheater is attached with a nozzle, and some air holes are provided inside the on the periphery of the inner wheel. Actually the exact model, so during operation of my chula, so this is the exact model of our design model, and also during operation, so whatever the flame is there, that the diagram indicates. Again, in our experimental setup, the major equipment is the superheater. The separate diagram of the superheater I placed here. The superheater, it is a cylindrical actually tube. The bottom end of the cylinder is attached with the supply of water tank, and the
Sir, you are not audible.
Just a minute, ma'am. Due to network issues, sir is disconnected. Sir is joining soon.
Okay.
madam, am I audible?
Yes, sir, you are audible, but you are only left with 1 minute only.
Okay, madam. Okay, madam. So this is the exact diagram of the this is the diagram of the superheater. The function of the superheater is to convert water supply to superheated steam. So this is the technology behind our work, and this experimental setup has been tested at IMMT. This is actually one of our central testing center is placed at Bhubaneswar. So that chula has been tested by taking some fuel as primary fuel, by taking 3 kg, 4 kg of fuel, primary fuel initially, and these are the thermal efficiency. That its range is in between 25 to 27% thermal efficiency, and the flame temperature is around 700 degrees centigrade, actually, which is twice than LPG or other operated chula. And due to complete burning takes place of our by using our chula, smokeless chula, so our power output is in between 4 kilowatt to 6 kilowatt, which is also twice than the traditional chula. And the flame temperature that I have already discussed, it is almost about more than 600 degrees centigrade, that is twice than the traditional and LPG operated chula. And due to perfect insulation, the handle temperature is in between 60 to 70 degrees centigrade, which is which indicates that our chula is not risk towards any, but it will not create any accident. And also the body temperature is in between 50 to 60 degrees centigrade, and the dilation ratio is in between 50 to 60, and the flow volume is in between 1 to 2 meter cube. So these all the experimental data, it indicates that our traditional chula is providing a healthy environment, and it is reducing, it is one of the innovative work towards reducing air pollution, as well as it is saves the health hazard of the rural women. And also the design and the implementation design procedure of our chula is very simple, and it's for its working purpose, no need of skilled person is required, and whatever the material required for developing the designing of the chula, that is also available in rural market. So that it is also one of the path towards creating entrepreneur to the young minds. And also our chula that have been tested, I have already discussed in one of our village, Baigani near Banki in Cuttack district, in the year of 2016, and recently we have also conducted one survey at Maidarpada, Cuttack. So these are our conclusions from our chula. It offers harmless home environment of the occupant and decrease the maintenance of respiratory diseases, because you know that air pollution is one of the reasons behind respiratory problems. The innovative of smokeless stove or chula is very fuel efficient, which needs less biomass for its operation, because the technology behind it that by using the superheated steam, the primary fuels complete burning takes place. Due to complete burning takes place, no need of extra fuel is required, and also at the end of operation, less smoke will less ash will be also there. And our superheated steam, this is one of the new concept behind our work. This is the innovative concept. Due to the provision of a superheated steam, the calorific value of the primary fuel, means the biomass or wood stove, increases, which gives the advantages behind the flame temperature. So these are some of the references, and now I am open for questioning.
Any queries or questions from audience?
This is a very nice presentation. I
Thank you,
think
sir.
that the carbon monoxide you are working on, the carbon
Sir.
monoxide is very bad for the environment. So
Yes, sir.
if you think that the glass and some more oxygen nearby, so the carbon dioxide will be better for far better from carbon monoxide. So if you think of the smoke with more black rather than smoke with like cigarette smoke, so it will be, I think, more better. So I want to ask that how did you experiment on this on the coal company? Okay,
No,
okay,
actually, sir, we have already developed two types of chula, one for
okay,
community kitchen and another for household purpose. So
okay,
whatever the operation diagram is given here, this is for community kitchen, for where we
okay,
can cook for more than 100 people, and our small size chula for the household purpose.
okay,
And
okay.
that in both cases, actually the cost of our community kitchen is around 10 to 12,000, and the cost for household purpose, its cost is around only 5 to 6,000. And
Okay, sir.
and whatever the concept, whatever the question you asked, sir, actually about regarding carbon monoxide and carbon dioxide, actually the concept behind it that actually we are using the secondary fuel as superheated steam. So actually the conversion of a superheated steam from water to superheated steam, the water, then saturated water, then wet steam, saturated steam, and the superheated steam. The during that conversations, whatever the energy given to the water for conversion of water to superheated steam, that all the energy that content with the superheated steam. So whenever that superheated steam added with the initial that burning of primary fuel, then at that time that all the energy converted to increase the calorific value of that primary fuel, so that our flame temperature suddenly decreases, suddenly increases.
Okay.
Because in this case we are
I
providing
think
high
that
pressure.
gross calorific value, right? Gross
Yes, sir.
calorific.
Yes, sir. Yes, sir.
Okay.
Gross
Thank
calorific
you,
value.
sir. I understood.
Sir.
Thank you.
Thank you, sir. Namaste.
Thank you, Ramesh sir, for your informative presentation. Now, I would like to call Soumyanath Tripathi with their paper title Time Multiplex Binary Offset Carrier Transmitter.
Yes, ma'am. This is Tamesh Haldar again. So he is my student. So I am on behalf of them. I am presenting.
Okay, sir.
This is the work on the time multiplex binary offset carrier, which is actually variation of the multiplex binary offset carrier. Multiplex binary offset carrier are two type. One is composite binary offset carrier, and another is time multiplex binary offset carrier. So here actually I working on this work, the time multiplex binary offset carrier, working in the GPS L1 band, which is actually 1575.42 megahertz. So it has the very strategic work. So because it has a time multiplex, so it has a 349 1933 few code combination are there, but here actually the modulation technique are the based on the multiple binary offset carrier, which why it is carrier, binary offset carrier. We had a BPSK in our college, but where the CDMA signal is multiplied with the carrier frequency. But here actually another sinusoid carrier actually multiplied. It may be sinusoid or it may be cosine, but so it is subcarrier, and it has the main peak in the frequency domain. In the main peak actually divided into two by using the subcarrier signal. So you can see that this is the TMBSC upper one data and the lower one are the pilot. So it is time multiplex. But I work on a coded, mathematically coded one work that uh, the composition changed to time composition. That means that we do not have to how to place the time multiplexing, that I work on the using the addition some constant, we can actually put it into the time multiplex option. So here the left hand side is this snapshot of the TMBOC signal, where the BOC signal is work and the binary offset signal is added. But how to fetch from switching, the switching mechanism I actually changed by adding the uh, constant. Okay, so here actually these are the data, these are the binary offset carrier modulation. So, and this is the code. This is actually the very crucial code what I have to do, that this 0.86 is 02503. By using this, I actually convert from one domain to another domain, from the spectral domain, from the time domain to the time domain. But the multiplexing means the switching thing, the switching operator has been changed by multiplying this. So these are the few references, and I am open for the question here. Thank you.
Okay.
Okay. Thank you, Tamesh. Mapping and tracking error of MBOC signal for GNS.
Yes, ma'am. This is my last paper, and this is Tamesh Haldar, and this is the last work of my students and mine and my teachers. So I am presenting the last
Yes.
presentation. So this is a spectral mapping and tagging error of MBSU signal for GNSS, which means Global Navigation Satellite System. So the GPSs, the GNSS actually work from the very previous work. So the minion it does over the 130,000 years ago, and after that the magnetic compass of the Chinese device has been worked as a fortune teller in Qin dynasty, which is 221 to 206 BC, and then the 850 and 1050 AD, the compass used as a navigation tool of the ship. Then after Kamal is came in the golden age of the Islam. Arabs are doing that. So after that mid-8th century, the compass, the sextant, all the measurementing tool are actually working. In the 18th century, John Harrison life's work led to creation of the marine chronometer, or the clock, is the finest work which has been done in our history. And by heritage we actually get the clock, and by this clock and the sending message, the trilateration of the three satellite, longitude, latitude, altitude, and another for the time, four satellite has been working on by to get a navigation system. So and what we get, the position, velocity, and time. So after that, the GPS transmitting on the L band, L2 band, L5 band. What is the L1? 1575.42 megahertz, 1227.6 megahertz, and 1176.45 megahertz is the main work. So and then that comes to the bandwidth. The GLONASS use 18 megahertz bandwidth in the L1 band, 16 megahertz bandwidth in L2 band, and in L5 is difference. So and this is a 120 in total from the many frequency has been working on the L band. Not only that, but also our India is working on the S band too. The L band is for transmitting, and for sending is S band. By this telemetry tracking, we can say that. But the Galileo works on the GPS, and other works on the 50 bps of navigation data, which is actually best work. But Galileo actually enhancing 50 to 250 bps. So it is now it is the best work. But we have to think in mind that the 0 means 1 and 1 means -1 in the bipolar decomposition. So this is the result. The MBSC signal and the L2 band signal, the Galileo signal, the L5 E5 signal is like that. The Galileo E6 has this, and GPS L1 and Galileo compatibility is there. What we get, we can, as I said, the sinusoid and the cosinusoid. The sinusoid has more less in the sinusoid has the less peaks, side lobes. Right hand side, that means that after the main lobe, but more in the middle. But cosine has the less in the middle, but right hand side is more. So when we do the filtering, then when to filter, that actually compromised. So and the thing is that this is the Kramer lower bound system. The Kramer lower bound based on the bandwidth and the autocorrelation function. So we can see that the binary offset carrier has the smallest tracking error, and then the time multiplies binary offset carrier. The highest one, the BPSK, has the more time and time tracking error. Why? Because the peak, as I said, the code correlation, the code phase and the Doppler phase have the this three-dimensional system where the power is the z direction. The upper line is for the BPSK, but the lower line, this under the triangle, is the BOC signal, MBOC signal. But what is the problem? The problem is it has the side peaks. It has the side peaks. That's why it is tracking error is crucial. But we also think of that it has the lower tracking error, so it has the higher peak. So in the time phase, code phase to Doppler phase. So that's why we are choosing the multiplex binary offset carrier. So by this, the GPS, GLONASS, Galileo are examined, though we are saying that the MBOC modulation scheme is the secondary main, but the changing is the difficult because we are working on the BPSK. But one thing of if we do the sinusoidal multiplication, by which we can actually change the signal. So how we can do that? We actually have the BPSK and the clock. If we clock it, if we multiply the clock to signal, then all the signal will be changed. Okay, so this is the references, and thank you. I am ready for the questioning. Yes, ma'am, your voice is breaking, ma'am.
Presentation. Any queries or questions? Meeting will be ending again in 5 minutes, so please join again. Till that, I would like to call Joshua D. Silva for their paper title, An Assessment of Artificial Intelligence and Machine Learning Application in Remote Sensing for Crop Classification. This is call for Joshua D. Silva, Riona Gonzalez, Prachi Dalvi, Swaranjali Modi.
Do we have to join the meeting again, or we'll present on this meeting?
You may start presenting. If the meeting ends, you shall join again and continue
Okay,
the
thank you.
presentation.
Crop and soil classification using satellite imagery and machine learning. So what's the importance of large-scale crop classification? Our world is currently experiencing a polycrisis, which is basically a result of many crises which combine together in order to create a global crisis. One of the main factors which contribute towards the polycrisis is the global food crisis. Thanks to the global food crisis, there's been an increase in overall world hunger. There are more than 828 million people in a state of hunger today, which is 150 million people more than that were in 2019. This also threatens the achievements of the UN Sustainable Development Goal. By geopolitical instability, such as the war in Russia and Ukraine, and also by anthropogenic climate change. Because of this hunger, we face a dual challenge, both of increasing our agricultural output and of reducing our emissions. To do so is extremely challenging because all the available farmland is currently located in the tropics, and conducting deforestation in the tropics will result in increased emissions and affect the biological sphere of the earth. Therefore, we need to carefully manage and shepherd the natural resources. And one of the ways to do so is through crop classification using satellite imagery. Therefore, we have gone through around 12 or 13 studies and then carefully selected them on the basis of quality and conducted a review. The first paper is a dual attention convolutional neural network using time series Sentinel-2 imagery. The study area is located in the county of Ak-Koala in Golestan, Iran. The main reason of the paper was to test out a specially designed deep learning based model in order to take advantage of all spatial, spectral, and temporal features of the crop data. It had 2 attention blocks and 2 common streams, which were then combined using a softmax layer to make predictions. It performed the best when benchmarked against all other models. The second paper was a deep learning based multi-temporal crop classification system. The study area was chosen in Yolo County, California, in the Central Valley, which is responsible for most of California's agricultural output. The objective was both to test the use of one-dimensional convolutional neural networks in classifying time series vegetation data, and also to visually work on neural networks in order to better understand them. The model chosen had the 1D